Okay, so integration, let's see. First of all, we have the integrations formula. So as you can see here, integrate ax to the power of n. So it becomes ax to the power of n plus 1. So that means the power increased by 1 unit and then divide by n plus 1. Okay, so divide by the power, the new power that we obtain, and then you plus c, plus c is a constant. So let's say, for example, I put one question here. Okay, if let's say I have 3 over x squared dx, so we have to integrate this. So remember that the x squared is now staying at the denominator and it is not suitable to integrate yet. So we have to bring the x squared up here. It becomes 3x to the power of negative 2, and now we can integrate. So it becomes 3x to the power of negative 1 over negative 1 plus c. So that is how we use the formula, where you can see the power from negative 2, you plus 1 to it becomes negative 1. And if the power, the new power is negative 1, then you divide by negative 1, then you plus c. So of course, normally we don't leave our final answer in this way, so we have to simplify it. So first we divide the number, 3 divided by negative 1, that will be negative 3. And then the x to the power of negative 1, we bring it down to the denominator, it becomes x to the power of 1 plus c. So that is how we apply the formula. Okay, now let's look at the next formula. So the next formula is a little bit different. So this one is ax to the power of n, but this one is ax plus b to the power of n, which means we have a linear form that takes power n. So when you integrate this, similar idea, the power n become n plus 1 and you divide by a. So a coming from the differentiation of the linear form. So imagine you differentiate ax plus b, you get a. So divide by a, and at the same time divide by n plus 1. Okay, divide by n plus 1 here. Okay, so we have to divide by two things. The first one is the differentiation of the linear form, where we get a. The second thing is the new power. After you plus 1 to the power, then you divide by that. So let's say, for example, if I have 4 to the power of 2 minus 3x to the power of 5. Okay, so again, if you realize that the linear form that takes power stay at the denominator, that means this is not suitable to do integration yet. So we have to bring it up. 4, 2 minus 3x to the power of negative 5. And after that, we can start using the formula. So when you integrate 2 minus 3x to the power of negative 4. Now this is the first thing, negative 4, where the power, negative 5, you plus 1 to it becomes negative 4. And then you need to divide by two things. The first thing is, you have to differentiate the linear form, 2 minus 3x. You differentiate that, you get negative 3. So you divide by negative 3. And after that, you have to divide by negative 4 as well, the new power, and then plus c. And after doing so, we simplified it. So first, we take 4 divided by, this is 12. 4 divided by 12 is 1 over 3. 1 over 3. The second thing is 1 over 3. The second thing is we bring down the bracket. So this take negative 4, right? The power is negative 4. So we have to bring it to the denominator. So it takes the power of positive 4. So it becomes 2 minus 3x to the power of positive 4 plus c. Okay, so that is how we use the formula. Now let's move on. Here, definite integral substitutes coordinates and find c. Okay, so that means if they give you limit, that is what we call definite integral. Okay, so if they give us limit, we have definite integral. Or another situation is, if you want to find c, right, basically they will give you a point. Okay, they will give you a point. They will give you a point where x is something, y is something. Then you have to substitute into the equations, the result. Then you can find c. Let's say one example. Okay, so let's say a question like this. I start from definite integral first. Definite integrations. This is basically revision also. Definite integrations, let's say I have, 3x, integration of 3x cubed minus 4x squared plus 5x dx from 3 to 5. Let's say I have this. So if you want to do this, what to do is you have to integrate. So 3x cubed, based on the first formula, it becomes 3x4 over 4. 4x squared you integrate, become 4x cubed over 3. 5x is 5x to the power of 1. So you integrate, it becomes 5x squared over 2. And then normally we put plus c at the end, but now because of the upper and lower limit, we don't put plus c anymore. We put 5 and 3 like this. And now there is no c for our case here, So we just substitute 5 into the x here, and here. So we put 5 here, and here. Okay, so we get 3, 5 to the power of 4 over 4, 4, 5 to the power of 3 over 3, 5, 5 to the power of 2 over 2, minus with, now we substitute 3. Substitute 3 into the x's here, and here. So, okay, we get 3 to the power of 4 over 4, 4, 3 to the power of cube over 3, then 5, 3 to the power of 2 over 2, and then we count, and we will get something. We get a number. Okay, so of course the calculation part I skip. I assume you know. So at the end you will get a number for definite integration. Okay, so for the case where you can find c, is in fact something like this. Let's say another example. So given that the gradient function is 3x squared minus 5 over x cubed. Okay, then find the equation of curve where the curve passes through point 1, 2. Okay, so let's say this is our situations. Okay, this is where we can find c. It's a situation where we can find c. So first, what is gradient function. You need to know this is dy dx. And what is equation of curve? It is y. So you know gradient functions, you know equation of curve. Okay, so what to do is you have to do integration. When you integrate dy dx, you will get y. Okay, so we just integrate that. We write like this first. Dy dx equal to 3x squared minus 5 over x cubed. Okay, then you want to find y, you integrate 3x squared minus 5 over x cubed. You integrate this. Okay, so you integrate that, you can get y, and that is equation of curve. So when you integrate, you will get 3x cubed over 3 minus, okay, so imagine this is 5x to the power of negative 3. Yeah? So now we integrate, we have to plus 1 to the power 5x to the power of negative 2 over negative 2 plus c. Simplify it. X cubed 5 over 2x squared plus c. Okay, this is the equation of curve, but the c is still unknown. So to find the c, we have to use the point. So substitute 1, 2. Substitute 1, 2 into the equation of curve. Okay, so the y is 2, the x is 1. So we will get something like this, and by doing this, or by solving the equation, you will get the value of c basically. So we have to do 2 minus 1 minus 5 over 2, so we get c as negative 3 over 2. So we get the equation as y equal to x cubed plus 5 over 2x squared minus 3 over 2. So this is the equation of curve where we get the c at the end. And remember how to get the c. Okay, so let's move on. Okay, so we look at the next subtopics here. To find area. To find area, so you know when we do integrations, when we integrate the curve, we can find the area under the curve. We have to know something like that. Huh? Okay, so you integrate the curve, that's the first thing. Second thing, you have to substitute the boundaries of x, and then you subtract one from another, ignore c. Ignore c is like doing like the definite integration here. So the curve you put here, the boundary of x you put here and here, the lower and upper limit, and then you do integration. Of course, this kind of integration there is no c involved. So that's why in general the formula is like this. Okay, let's see the general concept. Okay, the general concept is like this. To find area, right? So let's say you have a curve. So you have a curve like this, y equal to fx. And let's say you want to find the area from A until B. So you want to find this area. Okay, you want to find this area from A until B. So what to do is you have to integrate. Okay, you have to integrate. You have to integrate from A to B. You integrate fx dx. So that is how we find the area. Okay, in general, we have to do it like this. Now let's see in general how to find volume. We will go to area under the curve in specific after a while. So now we will look at the general concept in finding the volume. So the volume here is known as volume of revolutions. Volume of revolution. Okay, so what is meant by volume of revolution? So basically it means the shaded area over here, the shaded area, they will revolve, that means they will turn around the x-axis, for example. So something like this, they will revolve around the x-axis. So after that, they will form a shape. The shapes that it forms is going to be like a speaker or a bowl. Try to imagine, they will form a shape like that, and we have volume for this bowl. Okay, we need to find the volume. Okay, so of course, how to do it? Based on the information here, they said you have to square the function, you have to square the fx, or you have to square the y, then you integrate and substitute. Okay, integrate and substitute, use the same boundary, multiply by pi. So that means you have to do three things. Square, put limit, multiply with pi. So in general, the formula for volume of revolution is V equal to pi integrate a to b fx power 2 dx. So what you realize here is the idea of area, and volume is kind of similar. So area, you integrate the function from a to b. Volume of revolution, you square the function, then you integrate from a to b also, and you multiply with pi. Okay, so that is the difference. Okay, so now that is just general idea. Now we look at it in specific, how to find area under the curve in all kind of scenario. Okay, so let's see the information here. To determine the area under the curve, we can use definite integration. So which means integration with limit, lower and upper limit. The formulae: A, area of the shaded region. So this is the general situation. You want to integrate, you want to find the area from A to B. So you integrate from A to B, you integrate the y, that means you integrate this one. The y in terms of x, right? So you put it here, then you integrate with respect to x. Okay, so example, let's say you have a quadratic graph, y equal to x squared plus 2. So where here is 2. So now I want to integrate from -1 until 2. I want to find this area. Okay, so how to do it? Area equal to integrate from -1 to 2 x squared plus 2 dx. And then you have to keep doing to find the value, and the value that you get is the area under the graph. Okay, so now let's see the note. If the region is below the x-axis, negative value will be obtained. Negative value will be obtained. Let's say one example. Okay, I give another example here. Okay, now let's say if you have graph that look like this, y equal to minus x squared minus 2, and you want to find area, let's say from -1 to 2. So the area is from the curve to the x-axis, but it is in this way, So compared to the first scenario, this is like the other way around. So the area, we integrate from -1 to 2, we integrate -x squared minus 2 dx. Okay, so let's see the difference. Okay, so I do the top one first, just as your reference, you see the difference. Okay, so the top one, when I integrate this, x cubed over 3 plus 2x, 2 minus 1. Now I substitute 2 to the x's, 2 cubed over 3 plus 2 minus with -1 cubed over 3 plus 2 -1 equal to, okay, so of course we count this, 8 over 3 plus 4 minus -1/3 minus 2, okay, I get 9, so the area is 9 units square. Now you look at the second situation, you see the difference, negative x cubed over 3 minus 2x, 2 minus 1, substitute 2, now we substitute -1, okay, then we count this, -9. Okay, so you can see the difference where when the area of the shaded region is above the x-axis, you will get positive answer. When the shaded area is below the x-axis, you will get a negative value. So if you get a negative value, right, so what to do is, my suggestion, you put modulus. Okay, you put modulus because area at the end has to be a positive answer. So you put modulus from the beginning until the end, and at the end what we can say is it is equal to 9. Okay, it's equal to 9. Okay, it's a positive answer. Okay, now let's see more scenario. We look at B. Area of the shaded regions. So this is the formula. Area is equal to integration of x from c to d dy. So what's the meaning? You see the example here. If you have a graph y equal to fx in this way, so you need to rearrange, make x the subject, rearrange until you get x equal to fy, that means x in terms of y, and then you integrate the expression in y, the fy, in other words, you integrate fy from c to d. C to d is on the y-axis as well. Okay, then what you get is the area from the curve to the y-axis. Okay, so you see the difference between this and this. This one is from the curve to the x-axis. So what we integrate is everything is in x. So this is the second situation. You integrate everything in y. So then the area is going to the y-axis. So let's say, for example, okay, let's say example, I have, okay, let's say, put it here. Same equation, y equal to x squared plus 2. Okay, let's say now I want to find this area. Just now I already mentioned this is 2, right? So let's say I want to find 3 to 4. I want to find this area. You know, this area is from the curve to the y-axis, and because of that, what we need to do is, first, as you can see here, we need to rearrange the equation so that it takes the form of x in terms of y. So we rearrange this. So we get y minus 2 equal to x squared, and x equal to plus minus square roots of y minus 2. You know, you bring the power 2 to the other side, it becomes plus minus. So when it becomes plus minus, right, so which one should we take? Should we take positive square root or negative square root, right? So you may be wondering on that. It's very easy to decide. So if the area is taking positive x value, then you take positive. you imagine this particular point, which is here and here, the x values are positive. See, these x values are positive, and then you take positive square root. But if let's say you are finding area on this side, then the x value are negative, and then you take negative square root. Okay, so for our case here, you take positive square root. So in specific, that means here the blue one is positive square roots of y minus 2. Okay, let's say I use another color. This side it is negative square roots of y minus 2. So we have the positive part of the graph and negative part of the graph. So we have two parts. Okay, so we have to take the blue one. So we integrate like this. So to find the area, we integrate from 3 to 4. We integrate positive square roots of y minus 2 dy. Everything is in terms of y. So how to integrate this? You change it to y minus 2 to the power of 1 over 2, and then you integrate. Y minus 2 to the power of, you plus 1 to the power, it becomes 3 over 2. Then you divide by 1, divide by 3 over 2. 4, 3, and continue here. Then I substitute 4 minus 2, 3 over 2. The bottom simplify to 2 over 3 straight away. Minus 2 over 3, 3 minus 2, 3 over 2. Okay, so then we will get the area equal to something, let's say. Okay, so it's not a nice answer after all. Maybe it's in third form. Okay, so I just leave it blank like that. Okay, so likewise, I have to put another situation here. Just now, if you see the note, they say if the region is below the x-axis, negative value will be obtained. So this is the case. Below x-axis, you get a negative area. As you can see here, it is negative, and you need to modulus to make it positive. Okay, so how about the situation on the y-axis on this scenario? So the scenario will be kind of similar. If the region is on the right hand side of the y-axis, it will be a positive area. This will be a positive value. But if the shaded region is on the left hand side, then it will be negative. It will be negative answer. So meaning that, let's say I create another example here in green color. Let's say I want to find the shaded regions in green color from 3 to 4. Okay, so the area 3 to 4. Now this time we have to take the negative one. Square root of y minus 2 dy. Then we integrate. You will get a negative value. So what to do is we modulus everything from the beginning until the end. So the negative value at the end will become a positive value. Okay, so that is the difference. Okay, so you need to know something like that. This is the difference compared to the previous one. Okay. Okay, now let's see the next page. Okay, so as you can see here, at the beginning, they mentioned the same thing like what I said just now. if the region is on the left of the y-axis, the area obtained will be negative. So you need to do modulus to make the area to be a positive value. Okay, now we look at C. Area of the shaded regions for this situation. So if you still remember the explanation just now, if the curve is above the x-axis, the area found will be the positive value. But if the curve is below the x-axis, the area found will be a negative value. So this is positive, this is negative. Then what should we do? So we do it like this. We add out area 1 and area 2. So area 1, you see, the integration is from a to b, which fulfill the limit here, a to b. Then we integrate the curve with respect to x. So because this is area to the x-axis, so everything is y in terms of x. So you substitute here, then everything is in x. Then plus integration from b to c, which is here to here, b to c. Then the area is below the x-axis, so you should expect a negative answer. So that's why you have to modulus it. Okay, you have to modulus it. Okay, so let's say a quick example. Okay, let's say you have a curve like this. So you want to find this area and this area. So let's say this is y equal to, let's say this is 1, 2, 3. Let's say this is x minus 1, x minus 2, and x minus 3. So to find this area of the area that I shade, so what you do is you integrate 1 to 2 first. You cannot integrate 1 to 3 straight away. So you have to integrate 1 to 2, x minus 1, x minus 2, and x minus 3. So if you are wondering how to integrate these 3 brackets, we supposed to expand it first. Expand, get a cubic expression, that means power 3 expression, and then you integrate afterwards. Okay, plus modulus, integrate 2 to 3. 2 to 3, when you integrate it, it will be a negative value. So that's why we had to put modulus. Yeah, and keep doing it, then you will get one. Okay, so I assume this one settled already. Now we look at the next situation, another scenario. So the area here look like this. You have a 2 curve here. So the first curve is y equal to fx. The second curve is y equal to gx. And we are going to find the area bounded by the 2 curve, which is the area in between. So what to do is, we have to integrate from a to b. This is a. Okay, so let me do the correction here. This is actually a. Integrate from a to b, fx minus gx. So the logic here, fx minus gx, we have to know that when you integrate fx, right? So basically, you are finding this area in red, area under the curve to the x-axis, which is this area. The area in red color that I put just now. So it's this area. You found this area, but we don't want this region. This region is the extra region. So we need to minus with the integration of gx. So integration of gx, I put it in blue color. You minus away this part in blue color. So try to imagine. So the area in red minus with the area in blue, then the area remain is the area that we want to find out. Okay, so this is another scenario. Okay, so we move on. Next one, E. So if you want to find area in this way, so we have 2 curves here. The first one is x equal to fy, which is this curve. The second one is x equal to gy, which is this curve. So you want to find the area, the shaded area here. So you are going to use this formula. Integrate from a to b. A to b is the lower upper limit on the y-axis. So everything is in y for this case, fy. So why fy? Because the area that you get will be the area from the fy to the y-axis. It look like this, look like the red one. Then minus with gy. So when you minus with gy, right? So basically you are finding this area. You are finding this area. Okay, so imagine the red one minus with the blue one. So what remains is this. So that's why we have to do so. Okay. Now that's all about area. So we move on to volume of revolution in details, case by case, to know all kind of scenario. Okay. So volume of solid generated when the shaded region is rotated through 360 degrees about the x-axis. This is the first scenario. Rotate about the x-axis. Okay. So the formula we discussed through just now actually. Volume equal to integrate a to b pi y square dx. Pi y square dx. So you have to square the function. You have to put limit to the integration and you have to multiply with pi. Okay. So this one we discussed before. One example. Let's say if you have y equal to x squared plus 2 again, like this. Here is 2. Okay. Now let's say you have shaded region from -1 to 2. So this shaded region, right, when it revolves about x-axis, so you need to know what shape they form. So try to imagine. They form a shape like that. It has volume. To find the volume, we have to put pi. We can take out the pi and put it outside. Integrate from -1 to 2, x squared plus 2 square dx. So how to integrate? We have to square it first. So when you square it, x power 4 plus 4x squared plus 4 dx. So we have to do like this, and then you can integrate. Then you get a volume. Okay, so volume, right? Remember, it is always positive. It's always positive. That means even if you have a graph at the bottom, like the case just now, y equal to minus x squared minus 2, where the shaded region is at the bottom. When you find area, you will get a negative area. But when you find volume, it won't be negative one. So no need to modulus. Why volume won't be negative? You imagine if they revolve about x-axis, what they form is, they will form a similar shape actually. Same actually, exactly the same. You form a shape like this. Okay, so the volume, you have to square it, put limit and multiply with pi, and after that just go through the same process, expand it, then integrate, and then you get the volume. So it will be a positive answer. No need to modulus one. Although the shaded region is originally staying at the bottom, but it is still positive value. Okay, so now let's move on. Anything else? Okay, nothing else here. So we have to look at the next page. Okay, so now let's look at this page. Volume of solid generated when the shaded region is rotated or revolved through 360 degrees about the y-axis. So it will be like this. This is your shaded region. Your shaded region is, if you want to find area, you have to do like, if you want to find the area of the shaded region, you have to do like area equal to integrate a to b. This one had to do x in terms of y, fy dy. You have to find like this. So for volume, you can see just a small difference. Comparing this and this, you can see this one need to put a pi, need to put a square. So meaning that if you want to find the volume, you put a pi, normally we put outside, then you square it, and then you get volume of revolution. So this time it revolves about the y-axis. So you can see it form a shape like this. This is like a bow. Okay, so it form a shape of bow, then it has volume. So we want to find the volume. Okay, now let's see another scenario. Okay, C. So volume for this shaded region, revolve about x-axis. When they revolve about x-axis, everything is in x. When they revolve about y-axis, everything is in y. So now they revolve about x-axis. Okay, so the volume is, you see again, you imagine of the concept of area. You want to find the area of this shaded region, right? So basically, you need to take the blue area, the red color area, minus with the blue color area. So you have to minus in this way. The red one minus the blue one. So the red one is, okay, let me write down. If you want to find the area of the shaded region, so you have to integrate from A to B. You take the red one, minus with the blue one. Okay, now when it comes to volume, right, let's see the difference. The fx minus gx is still there, but you need to square it first. You square the fx, square the gx, then you minus them, then you multiply with pi. Okay, there is a similarity between area and volume. So volume need to square and pi. We square individually. We don't square the whole thing. We square this one, we square this one, then you integrate. Okay, then you multiply with pi also. Okay. Now last one. So let's see this situation. They revolve about y-axis. Is this shaded region R, revolve about y-axis. Okay, so everything is in terms of y. So let's say we talk about the way to find the area. If you want to find the area, right, you have to take the red one, minus with the blue one, the blue region. Okay, so if you want to find area, I always build up from area, because if you understand area, then volume is just similar. You integrate A to B, integrate Fy. Fy will be the red color area, minus with Gy. So we find it in this way for area. Now let's see the difference. Small difference only. When it comes to volume of revolution about the y-axis, so you square each of the functions. You square this and you square this, then you multiply with pi. Then you will get the volume of revolution. Okay, so no more already. We finished the theory.